In this video, I'd like to show three different ways of expressing solution concentration. And we're going to do problem number 60 that you see on your screen, which is just, it's a chemistry problem I do with my students. And again, what we're going to do is we're going to do percent concentration, molarity, which I've discussed in a separate video, and molality, which is slightly different. And you'll see in the question it asks you to solve for all three of those. So let me just kind of go through these. First of all, for percent concentration, I think this is relatively straightforward. I have a solute here. I have calcium chloride as my solute, and I'm adding 21.5 grams of that to 63 grams of water. So to get the percent concentration, you want the percent of the solute over the mass of the entire solution. So for the percent, I'm simply going to take that 21.5 grams of solute, the calcium chloride, and divide that by the mass of the entire solution. So I'm going to add the 21.5 to the 63.0, and I'm going to get a total solution mass of 84.5. If you times 100, do your math and times 100 there, you're going to get 25.4%. Okay, so that's a pretty straightforward just percent concentration. Molarity, which I've discussed in prior videos, I abbreviate with a capital M. That is going to be moles per liters of solution, of the entire solution. So my moles is going to be my mass over my molar mass. Well, let's figure out that molar mass briefly here. Calciums are 40.1 grams. Chlorines are 35.5 on the periodic table. I have two of them, so that's going to add to 71.0. When I add all these together, I'm going to get 111.1. So my number of moles in this case is going to be my mass, 21.5 grams, over my molar mass, and that's 111.1 grams per mole. And you will see the grams will cancel, and I will be left with a number of moles. And now for the liters of solution, okay, this is a bit of an issue, and so we have to discuss this. So you'll see the density I have circled of my material. When I add that solute up here, the density is 1.20 grams per milliliter. Well, I am given in the problem, I am given that my mass of the solute is 21.5, my mass of my water 63, and we've previously seen that that mass is 84.5. Well, what I need to know is need to know the volume in liters. So if we know the density is mass over volume, in this case we know my density is 1.20 grams per milliliter. They give me that in the problem. I know my total mass of my solution. They tell me that, or I figured out when I add the 21.5 to the 63, my mass is 84.5, and then my volume is what I'm trying to find because I need that to do my work. So I rearrange this, and the volume will go up, and the 1.20 will be below the 84.5 if I rearrange this. And so it turns out that my volume would be 70.4 milliliters, or I could express that as 0.0704 liters. And so there is my volume in liters, 0.0704 liters. So now this represents the moles. The denominator represents my liters of solution, which I have, and again, molarity is moles per liters of solution. So now I can do my math, and in this case I'm going to get 2.75 molar. Sorry, that 5 doesn't look so good, but 2.75 molar solution. Now, to find molality, molality is similar, at least the numerator is certainly the same. It is moles. But rather than dividing by liters of solution, we're going to divide by the kilograms of the solvent, of just the solvent. So my numerator is the same as it was here a second ago. It's going to be the same 21.5 grams over 111.1 grams per mole. Okay, that will be the number of moles. But now in the bottom, I'm going to divide it by the kilograms of solvent. Well, 63 grams is 0.063 kilograms. And so when I do my math there, I'm going to get 3.07, and that is a lowercase m for molality. So again, you'll notice the similarities here. Molarity and molality. Molarity is moles per liter of solution. Molality is moles per kilogram of just the solvent. So you do need to be somewhat careful when you're doing these sorts of problems. Thank you very much.